Hello and welcome back to Topper Machine. I'm Josh Topper, and as you can see, we're out here at the steam engine today because you know what that means. We're going to make the piston, so let's get in the shop and get started. Now, if you remember a while back, we bored the cylinder on the horizontal boring mill, and we got that true, honed. It's just beautiful, and I have my finished size on that. So the piston being a different material, we had to calculate out the coefficients of thermal expansion, and obviously the cylinder is going to be a different coefficient of thermal expansion. And I also did some testing on the materials, so we know what the actual expansion rate is. And here is our material for the piston. This is a chunk of 7075 T6 aluminum, about $750 for this piece, so we don't want to screw it up. And I have the original piston out and apart so we can figure out roughly what we need, but because we bored it oversized, we need a different piston. So that's why I'm going with the aluminum here and not just reusing the original. All right, so this is the original piston, and it is the original. And what's really cool is this is a cast iron piston, but it is hollow. So these are, it's a lost wax, I believe, casting, so that they can just melt out the, hollow it out that way. It is hollow, it is very light. For its size, it doesn't weigh much. And when I'm done, my aluminum piston will actually weigh less. So what we've got to do is just to make the body, make the ring grooves, bore it for a taper also, but I'm also going to dish the faces on both sides for a little bit more steam space. So we'll have a little bit more power. Actually, essentially stroking it is kind of what we're doing, or some people would say like a hemispherical head, except it's the piston is. So we're just creating more steam space for more expansive force for more power. So that's what we're doing with the aluminum piston. So let's get it up in the lathe and let's get started on the turning. Okay, so I got my 3-jaw chuck here, jaws reversed, and what I'm going to do is take some of these little rare earth magnets and just use them as a spacer, because I don't need the depth to turn this piston. And I'm just going to get it out there where I want it. Jeez, if I can separate these magnets. And all I'm using them for is a spacer, nothing more. We're just going to touch the aluminum up to it and then tighten it down. And they're not going to do anything, but they'll at least stay put. Now the whole goal here with spacing it out is to do it all in one shot, all the machining, and I'm hoping we'll have enough there so that we don't have to put it in the 4-jaw to, face off. I'm thinking we'll be able to get enough clear to just flip it around, grab it, and just face it off to lengthen. All right, let's spin this thing up and see how she looks. That's 500 RPM. That's probably where I'm going to run cutting this thing. It looks like it's probably going to be just fine. This is 10-inch diameter, so we've got quite a bit to take off. We're taking it down to 9.280. All right, so the very first thing I'm going to do here is bore my starter hole through, and I'm using the 1¼ spade drill. I'm not going to set up the flood coolant just for one piece as far as through drill, but I will do it this way and throw coolant everywhere. All right, now we'll get this thing faced off. All right, now we need to go in and just kind of figure out where the end is, where we need to stop. We're going to bring it right up to the jaw. I'll just bring it in, and we're going to stop about there. But with each progressive cut, we're going to come in deeper. So we're actually going to utilize the chamfer on that tool there to get in a little further for each cut. In fact, I might change my tool angle just to gain a little bit more, so that when we do face off this side, we don't have to worry too much about matching up. Okay, so I just changed my tool angle quite a bit here. We still have clearance on the back side of our tool, but that gained us a lot more angle, so that'll gain me a lot more depth to come in and, you know, creep in past that that diameter. So that'll work perfect. All right, I got my distance figured out. I'm gonna zero my readout, and I'm gonna come in and take about 120 in this first pass. Actually slow down my feed rate, and we'll just go into the stop there. All right, looks like 100% cleanup. Let's just get a rough measurement with the caliper and see how far we got to go. We are at 9.937 with the caliper, and we got to go to 9.280 for our final diameter. Now, as nice as that cut, I did not like how it was throwing those chips, so I slowed her down just a little bit. I'm gonna take another 130. Actually, we could take more. Let's take 200 on this pass. We should be fine. We got plenty holding. And let's get it there quicker. All right, so I got just over 400 more to go, and I'm getting a nice surface finish, but it is throwing aluminum everywhere. This is a messy job. 6061 doesn't react quite like this. This being 7075, it's a little bit harder material, so I think that's why it's doing what it is. So I just got to keep my distance. And I'm going to slow it down on our next pass here. So I'm sure you've noticed that little spark every so when I get to the end there, and I don't know, you probably can't see it, but I'm just kissing the edge of the jaw, but coming in deeper, and I've already gained about 50 thousandths on my depth here. It's just touching it with the insert, not actually hurting the insert, so that's all good. But we'll get one more pass here, heavy pass to get down to close to size, and then we'll speed it right back up for finishing. All right, so I'm feeling a little heat coming into it. We'll just cool it off a little bit. We're trying to maintain a temperature, you know, roughly tool room temperature is 68 degrees. Try to maintain as close to that as possible for my calculations for thermal expansion. So the cooler we keep it, the better during the machining process. But I don't want to throw coolant everywhere either. So we'll cool it off, and then we're going to run 710 RPM for the next 2 passes, which should finish off the diameter. Well, that cooled off really fast. Now we'll grab our 9-inch micrometer here, and I already just checked this to a standard, and we are good to go. We were at 9,350, and we got to go to 9,280. And by the calculations, this is going to be a loose fit in the cylinder when it's cold, but once it's up at running temperature, about 350, 370 degrees, roughly there, we're going to have about 10 thousandths of clearance, so between the piston and the cylinder wall, which will be about perfect. All right, so that was 710 RPM at a slower feed to get a nice surface finish. And as you can see, I am just covered in aluminum, kind of the hazard of the job. But we'll get this measured, see how much more we had to take. I took 35 thou in that pass, so we should only have about 35 thou to go. I don't know if that shows up on camera, but I have 40 thou to go. Let's see how we did. I don't know if this shows up on camera within the focal point, but 280. So 75 plus 5, 280, right where we wanted to be. Absolutely perfect, spot on, couldn't ask for better. All right, the next step here is to turn the grooves for the rings, but I know there's going to be a common question that everybody's going to ask is why the difference in the bore? We know the bore is 9.310, 311, somewhere in there, and the piston is 9,280. Why the difference in size? Well, the rate of expansion of the cylinder is different from the rate of expansion of the aluminum. Now, by the calculations of everything I've done and the testing I've done, I've found about 35 to 36 thousandths increase in diameter of the aluminum piston. The bore, the cylinder, is about 15 to 16 thousandths. So to maintain about a 10 thousandths clearance, that's where I'm at. So I am, technically, I'm 30 thousandths undersize as far as the piston goes to start with, but when we're up at operating temp, which doesn't take long with the steam, we're going to be about our 10 thousandths clearance that I want. So there's a lot of calculations involved in this stuff when it comes to the thermal expansion. So and being proficient at it is not something I am. It took a long time, a lot of sitting around thinking and calculating and figuring until I finally came to these numbers and these conclusions. So The 10 thousandths clearance is not going to be an issue. It's just going to give me a little bit of safety. I could go tighter, but I just feel I'd rather have a little bit of safety, and with good rings in there, we shouldn't have any issues. Alright, that was screaming a little bit more than I like, so I decided to slow her down just a little more and see if that helps. That sounds better. And we're going in 730 thousandths total. Alright, my depth is good. Now we need to widen it out for my finished size. Alright, let's just see if my ring fits. Yeah, beautiful. Snug enough that it's not going to be a problem when it cools off again, lock up, but loose enough that it will float. So perfect. Just what we wanted. Now I'll move over. I'll cut another ring groove over here. All right, next thing we're gonna do here is actually recess this side about a 1/2 inch. That'll give some nut clearance, but also should give me clearance, well, some more steam space. So let's go ahead and take this in a 1/2 inch. And obviously my center hole isn't big enough for my boring bar, so we'll have to work at this a little bit. All right, if you caught last week's video, you saw me make this tool, and this tool was for I was for this purpose all around, doing this piston, but I had a job that I had to do with it, so that worked out even better because I got paid to do the job and make the tool to do it. So now I have the tool to do my piston. So we're going to come in and we're going to put a big radius here, and we're actually going to come in a little bit deeper and put a radius up to the shoulder, roughly where the nut sits. So we'll have a nice little dip in there. All right, that came out absolutely beautiful. Exactly what I wanted. And I hope that squealing wasn't too terrible. I'm gonna try to play with that a little bit in editing throughout the video. So, but this is stunning. This is coming out perfectly. We're gonna do a little bit more on the other side, just because we have to compensate for the rod on that side. But God, that is beautiful. Come out nice. And finishing touch on this side, and we're done with this end. All right, flip it around, face off the other end, and with any luck, we won't have to do this in the forejaw to finish the other side. And if we do, we'll just have to put the forejaw in. I'll just chuck lightly on it so as not to crush the aluminum. I suppose a couple of pads wouldn't be bad, but I don't think we need a lot. And we'll just check it, see how it turns concentricity-wise, but I think we'll be okay. I think we can live with that for a 3-jaw. Looks pretty good. All right, so for this end of the piston, we're gonna leave the center protrude all the way because we want as much as possible to grab the rod, especially when we get the taper, but we're gonna come in somewhere about here to there, and we're gonna cut a nice deep radius in there, probably go 3/4, maybe a little deeper than that, just for the steam space. Well, that's going nicely, but before I get too carried away, I'm gonna go run some volume calculations and figure out, you know, how much volume I have on one side versus the other and get everything dialed in right where we need it. And then we should be good to finish this guy off. All right, there she is. Wound up going 7/8 of an inch deep to compensate for the differences. The rod on one side and nut and everything on the other, so we're good here. We'll go ahead and get it out of here, go over to the Monarch lathe, and we'll do the taper for the bore. All right, so I'm over here at the little Monarch because, quite honestly, the Monarch has a better taper attachment than the Lion. I've used the taper attachment. In fact, I don't know if the videos will be before this one or after this one of the taper attachment, but I did do a job with it, and it worked. It worked fine, but it's not as smooth as the Monarch one. So that's why we're gonna do this in the Monarch. And I've cut some shims. We're gonna put those on the jaws so as not to mark up our beautiful piston here. And we're gonna cut a 1 degree taper. And we'll just get that taper cut to size. And then next week's video, I guess we'll make the rod, the piston rod. That's a chromed rod. Taper cut on one end, threads on both ends. Pretty simple, straightforward job, but we'll do that next week. All right, so there's been a lot of controversy over the last few years of me doing these videos and people saying I don't know how to use a 4-jaw chuck. Well, I do. There's just not a place for them every day for every single job. I mean, 3-jaw is great for a lot of things. So we got a little bit of straightening out to do, so I'll go ahead and get that done. I don't think it's getting any better than that. All right, taper attachment's set up. We're just gonna come in and we're gonna just whittle away at it until we get where we wanna be. And this is the back side, so we're just opening up this side. All right, so my rod is 1.5 inches, and I'm gonna taper it all the way, no shoulder. And as long as I'm under 1.5 inches, we're good to go. So I'm gonna take another, well, there's 100. I'm gonna take another 120. We're gonna go to 450. That way that we have more room to push it on. So let's keep cutting. This should be the last pass. That'll work. All right, let's get this thing out of here and take a look. But from so far, what I see, I'm very pleased with this. That is absolutely a thing of beauty right there. This is going to work amazingly well, and it already feels a lot lighter than the original. Well, I could not be happier with the outcome of this. This came out just absolutely beautiful. And for $750 worth of material, I'm glad I didn't screw it up. So it's definitely going to be a vast improvement on the steam engine, having a properly sized piston, a bored cylinder, good rings, and then tune in next week when I make the piston rod. So that's 1045 chromed rod we're starting with, so what I use for hydraulic cylinders. And then we'll taper it and thread both ends for the one end threads into the crosshead, the other end threads a nut on out here. And I'm not sure yet how I'm attaching this. So if we're gonna heat up the piston and slip it onto the cold shaft so it locks, that might be the smart money, and then cinch it down with the nut. We'll see when we get to that point. But I hope you enjoyed the video. Thank you for watching and sticking with me all these years and watching the channel grow and improve. And with that, until next time, get out in your shop and get it done right the first time.